Welcome back. This is the lecture on Chapter 9, Multivariate Correlational Research. This chapter looks at several things. First, we're going to review the 3 causal criteria. Then we're going to talk about temporal precedence with longitudinal designs. Temporal precedence being one of those 3 causal criteria. Then we're going to talk about how we can rule out third variables with multiple regression analysis as a type of statistical approach. And then we're going to talk about getting that causality with pattern and parsimony. And then a few design things, including mediation, which is a sort of third variable that is more informative. And then multivariate designs and the 4 validities is what we'll finish with. So first, in multivariate designs, it involves more than 2 measured variables. And when done correctly, it can help establish causality. And as a review, the 3 criteria for establishing causation, you need covariance, temporal precedence, and internal validity. So covariance meaning they go together. The variables, when one goes high, the other one goes high or goes low. Temporal precedence meaning the thing that causes the other thing must come first. You can't have it in reverse order. The thing that causes it cannot happen second. And then internal validity. The relationships need to actually be between those 2 variables and not anything else. We're going to spend a lot of time talking about that using multiple regression. So to establish temporal precedence, you actually can use what's called a longitudinal design. So longitudinal just means over time. So basically it'd be like having a study that has time 1, people come in and do something, and then you bring them in again, and then you bring them in again sometime later. So there's 3 main correlations to interpret in a longitudinal design. First is cross-sectional. Second one's autocorrelations, and the third is a cross-lag correlation. These will become more clear in the next slides. We're going to also answer why don't we just do an experiment? Wouldn't that be easier? Just do a single experiment and be able to talk about causation that way. So first, cross-sectional correlations just means a correlation between 2 or more variables at the same time. So overvaluation at time 1 and narcissism at time 1. So these don't correlate a ton within time. Here they correlate a little bit more, here a little bit more, and this one a little less than this one. So these are cross-sectional. That means you're just cutting the study and looking at one time point. Autocorrelations, on the other hand, is the correlation between the variable and itself at different time points. So the same measure from time 1 to time 2 is pretty highly correlated, almost 0.7. 0.6 here and 0.6 here. And about 0.5 across the board here. So these are called autocorrelations. They are correlations with the own variable over time. And then there's cross-lag correlations. These ones are really interesting because this one starts to show what does this tell us about the other variable at the next time point. So overvaluation does somewhat predict narcissism at time 2. Overvaluation, again, from time 2 to time 3, and from time 3 to time 4. Interestingly, narcissism does not predict overvaluation at the next time point. So this would start to give us a clue that overvaluation is what is influencing narcissism and not the other way around. So longitudinal studies can give us each of these. Longitudinal designs are really good for showing us covariance. So for example, in this one, it showed that overvaluation and narcissism covary even over time. It also shows temporal precedence. So this one came first, this came second, and this one does predict this one. And then internal validity. We'd have to ask the question, is there anything else that could be happening at time 1 that could influence narcissism at time 2 that we're not accounting for? If we're not accounting for it, then we may be lacking in internal validity. But if we're accounting for all the things that we should, then we could have all 3 criteria in a longitudinal design without needing an experiment. So the question is, why not just do an experiment? Well, in many cases, participants cannot be randomly assigned to a variable. So think of some situations where you can't actually assign someone. So I have one like you cannot be assigned to preferences. So you can't say, okay, you're going to prefer music to a different hobby. It also can be unethical to assign participants. So in those situations when it's unethical to assign participants to a group, for example, like assigning people to smoke cigarettes to find out if cigarettes cause cancer. Really early on, researchers figured out it's not safe to assign people to smoke because it likely causes cancer. So they had to use longitudinal designs and watch as people, when they chose it themselves to smoke, were they more likely to get cancer? So this is going to happen sometimes where you either can't, because you can't assign someone their preferences, or it's just unethical to assign participants to do something that could be damaging. Longitudinal designs are really good. But even in those designs, you still have issues of ruling out third variables. So for a long time, with the tobacco companies, they would argue that there could be a third variable explaining why people smoking were more likely to get cancer. They'd argue, oh, it's because certain types of people smoke. It's lower SES, or it's people that live in cities. There's other reasons that could cause cancer in the lungs other than the smoking. So one of the things we can do to try to rule those variables out is use multiple regression. And multiple regression essentially controls is the term for another variable. It means that it holds it constant. So it says making everyone the same on where they live, does smoking still predict getting lung cancer? So in essence, it's controlling for that variable. It's saying it's not attributable to that. So consider this example. So pregnancy risk and exposure to sexual TV content. So just looking at raw data, it looks like there's a relationship. As you are more exposed, your pregnancy risk goes up. But consider 2 different situations. One that's probably more realistic, where age is related to both pregnancy risk and exposure to sexual TV content. So 16-year-olds are less likely to get pregnant and have less exposure. 18s more and 20s even more. Over here, there is no relationship there. 16-year-olds aren't any less likely to get pregnant and they're not any less exposed. So in this case, age might explain this positive relationship between exposure and pregnancy risk. It may have nothing to do with exposure at all. It might just be age. In this situation, it doesn't look like age impacts it at all. It could just be the exposure to sexual TV content. So regression results actually indicate if that's the case. So we're going to use a model, this regression model that looks at the relationship of exposure to sex on TV and the outcome, which is pregnancy risk, when controlling for age. So statistically, but underneath the hood, it's really just making everyone the same age. And then it says, what happens with exposure? Does it still predict higher pregnancy risk? In this case, we get a beta of 0.25. Beta it's a lot like R, the correlation coefficient. It basically just tells us the effect of a predictor controlling for the other variables. We also find that age does predict higher pregnancy risk. So as age increases, you're more likely to get pregnant. So again, beta is similar to R. So positive beta indicates a positive relationship between that predictor variable and the criterion or the outcome when the other predictors are statistically controlled for. So the question is, how do we interpret that 0.25? What does that actually tell us? It's telling us something about the relationship between exposure to sex on TV and pregnancy risk when we make everyone the same age statistically. But here's some examples. So if it's significant, and in this case it is, you could say the relationship between exposure to sex on TV and pregnancy is positive. That is, high levels of sex on TV are associated with higher levels of pregnancy risk, even when age is controlled for it. So that's one way you could do this. Another, the relationship between exposure to sex on TV and pregnancy is positive, even when age is controlled for. Another one, the relationship between exposure to sex on TV and pregnancy is positive and is not attributable to the third variable of age because it holds even when age is held constant. All of those work. They're all trying to get at the idea of when you make everyone the same age, does exposure to sex on TV still relate to pregnancy? So there's going to be some cases where when you control for another variable, it's going to make your predictor, the one you're most interested in, not significant. So in this case, we're looking at academic success as the outcome, and we're predicting from frequency of family meals. And then we also have a variable parental involvement. And so when parental involvement is controlled for, the frequency of family meals is not significant, which means it doesn't look like there's any effect. So we don't even need to really consider this beta. Even though it's negative, it just doesn't mean anything. There's really no effect. On the other hand, parental involvement looks like it is positively related to academic success, and it's significant. So here's some ways that you could interpret a non-significant beta of the negative 0.01. I'm not going to go into detail on this, but all of these work just great. So in some of your studies, you might see a multiple regression result table that looks like this, so there's exposure to sex on TV, and then total TV exposure, age, and there's a bunch more other variables. So still, exposure to sex on TV is still saying controlling for all of these, or making everyone equal on all these, there is an effect of exposure to sex on TV, and it's significant. So 0.44. So as you watch more sex on TV, you're more likely to have a pregnancy. So when it says being female, that's a categorical one, or being black or Hispanic. What those tell us is, regardless of your sex or your race, this is the effect of this variable. We also can interpret these betas as well. We can say age has a positive relationship when controlling for all of these other variables. So controlling for exposure and total TV exposure, etc. Being female, being black, etc. All those say those have a relationship with risk of pregnancy. So in the popular press, you're going to see terms like controlled for, taking into account, correcting for, or adjusting for. Basically, all those are trying to get the same thing, that in some way they controlled for another variable, a third or fourth variable that could be impacting the results. So one thing to be aware of is that multiple regression is not a foolproof way to rule out all kinds of third variables. It's a good way to control for things, to make things equal on some variables and control for possible third explanations. But there always could be another variable. So often what is actually going to have to happen is we're going to need time and consistent results showing that there's a relationship regardless of the variables that we control for. So in this example back here, we're approaching this where we could probably say more exposure to sexual TV content causes higher risk of pregnancy. But this can be problematic because of what I was mentioning. Multiple regression can control for third variables, but here it can't establish temporal precedence. We don't know which one came first. Maybe getting pregnant causes more exposure to sex TV. There also could be another variable that we didn't measure that we should have. So there could be something about possibly where they grew up or something cultural that we didn't control for here in some way. So when it comes to using longitudinal designs to get at something that's causal, the smoking example is really good. So for a long time, the tobacco company kept saying, no, there's another third variable. And so they would control for other variables and they would still say, no, there's more. So over time, what we started to see was this pattern. This pattern of the longer a person has smoked cigarettes, the greater the chances of getting cancer. That was one. People who stop smoking have lower cancer rates. Smokers' cancer tend to be in the lungs in the same type. Smokers who use filtered cigarettes have somewhat lower rate of cancer. And people who live with smokers could have higher rates of cancers too because of their passive exposure to the same chemicals. So even though one study didn't show all of these at once, there are many studies that show different aspects of this. And really soon we started to get what's called parsimony. Parsimony is simplicity. It's the degree to which a good scientific theory provides the simplest explanation of some phenomenon. So the simplest explanation across all of these is that smoking causes cancer, specifically in the lungs and usually of a particular type. So when we're looking for causal explanations of things, this is what we're looking for. A strong pattern that seems to hold across many studies, and parsimony, something that is straightforward, that provides simplicity to how something is occurring. So in the book, it talks about how these are represented in the popular press. So journalists don't always fairly represent pattern and parsimony. They usually just report on one study at a time, and they are selectively presenting only part of that scientific process when they do that. So personally, I believe journalists do their best, given their role is to make studies easy to understand and apply. But it is cutting corners. Science doesn't work with just a single study. So in general, this third variable issue actually can be broken up into either a true third variable, a mediator, or a moderator. Those words are very similar to each other. We're going to talk about what this actually means. So in this figure right here, what this figure is trying to say is that the amount of deep talk influences the quality of social ties, which in turn affects well-being. We were showing that before the amount of deep talk affects well-being in some way. They're related. But it could be that this is affecting well-being through the quality of social ties. So it's not so much that deep talk directly affects your well-being, it's that it affects your quality of social ties, which then is what is helping your well-being. So this variable right here, quality of social ties, would be called a mediator. It mediates the relationship between amount of deep talk and well-being. So when it comes to mediators versus this third variable idea, similarities between the two, they both involve multivariate research designs, and both can be detected using multiple regression. However, third variables are external to the bivariate correlation, which is problematic. It's not related to the causal relationship between the two variables. So like this case, education level could be impacting both the amount of deep talk and somebody's well-being. It isn't between these two. This on its own is impacting both. So the relationship between these two is just because they're both caused by education level. Mediators, on the other hand, are internal to the causal variable. It's not problematic. So going back to this situation, the quality of social ties comes from deep talk. So it helps explain how the amount of sleep actually impacts well-being. Where in this case, this doesn't explain how amount of deep talk affects well-being. Instead, it says it has nothing to do with amount of deep talk. It's just the education level that impacts both of them. So in general, I would look at mediators and say, those ask why. Why does deep talk affect well-being? Well, it looks like it's because it affects the quality of social ties. So mediation is, why are two variables related? There's also this moderation. Moderators ask for whom or when does a relationship happen. So are certain groups or situations for which the two variables are more strongly related? So is A and B related for some part of C and not for others? And then the third variable problem is this, where C is what's causing the other two. So consider these examples. So for mediation, we have viewing violent TV impacting becoming desensitized to violence, which in turn affects aggressive behavior. So in this one, becoming desensitized is the mediator. Viewing violent TV impacts this, which in turn impacts this. Moderation, on the other hand, would say, so when parents discuss the TV content with their kids, violent TV viewing that is not correlated to aggressive behavior. However, when parents don't discuss it, there is a relationship between the two, and it's a positive relationship. So that's moderation. The moderator would be whether or not parents discuss the violent TV with their kids. Third variable problem would be, do you have lenient parents? If you do, maybe that leads to more aggressive behavior and it leads to viewing more violent TV. This view would say these two aren't actually related to each other than they both were created by having lenient parents. So in each of these situations, we have this third variable happening, but mediation is a specific type, moderation is a specific type, and the third variable problem, this is the only one that is truly a problem. It means there really is no relationship between these two. It's just this. This is what's impacting it all. So when it comes to multivariate designs and the four validities, we're going to talk about each of these briefly. So interim validity is asking the question, are there other ways of explaining the results? Or are the relationships between the predictor and the outcome causal? Construct validity asks, are your variables measured well? Are they measured reliably and validly? External validity is saying, would we see this in the population in general? Would it happen in other situations, in other contexts? Without as much control, would this still happen? And then statistical validity is asking whether or not the effect size is meaningful and is there significance? Do we think this is happening in the population? So in the case where we had the sex on TV and pregnancy study earlier, we found the beta was 0.44, so that's the relationship between sex on TV exposure and pregnancy risk. And this was statistically significant. However, something to keep in mind is there's no guidelines for what constitutes a large or small beta. So it actually depends on the situation itself. And so we need to not just look at how big is the effect size in terms of the statistics, we need to look at it, what does this mean in context of this research problem? So that concludes chapter 9. Remember, the method section is due this week. If you have questions about it, please reach out early so that we can work out how to do it before you're pushing the deadline. For the method section, you can use anything that we've covered so far in class, or even something from later on if you've looked at that stuff. But please reach out if you have questions.